Well, I guess we can start. Welcome back, everyone. So I've put here that we have just 15 more weeks to go. All of our weeks are going to be numbered. So we'll be marching down through the Canvas course page on the 16-week semester. But this is also great. We're getting through the first week. At this point, you know kind of how this course is going to fit in with your other classes in your overall class schedule, how this course might fit in with work, home life, and these kinds of things. And the best thing to think about now over the weekend is how to get in a routine to habitually come back to this course, work through the homework, work through the studying, those kinds of things. The more you can get into a routine and a habit of just doing those things, of coming to class, reading the book, and doing the homework and the quizzes, the easier it becomes week by week as a basis. And everything I'm doing on this Canvas, it's also going to be kind of a ritual, routine, and habit for me as well. I'll always be duplicating the way things appear on this course page and move around. So you'll always know just about what to expect in the course. One thing that you might have been expecting, however, is we did say we're going to do weekly quizzes. But I felt like it was a good idea to hold off our first quiz until next week because we had a lot on our plate just getting started off the ground on this week. So what'll happen is on an actual week where we post a quiz, that's going to be week 2. Let's pretend it's on this week. The quiz will appear as a quiz. This will no longer be hidden. You'll be able to see it yourself. It'll just contain some instructions on how to fill it out, how to submit it. I'll give you multiple ways to hand in your quiz. And we'll have a due date and a link to a PDF question. So it'll be kind of like a traditional book question. You'll just pull out a piece of paper, solve the quiz, either hand it in as a physical copy, or if you are working on it digitally, you could email it to me as well. We'll rediscuss that as we get closer to our next Thursday when we actually release a quiz. So sorry for not posting it if you were anticipating it this time. I felt like week 1 is kind of cruel to throw too much out at once. But any questions so far? Okay. Aside from that, I don't have too much to say for the announcements. We won't take too much time for the announcements every day. Usually it's just going to be a quick roundup of things to mention. Like, for example, this is nice. We're already due for a holiday, Labor Day, on next Monday. So we'll reconvene after today on Wednesday's class. Aside from that, let's go right to where we left off on. We left here. So that's a lot of information to throw at you. But that's one of the reasons I'm always going to put on the Moodle website the actual work that we put in. So you can always check back here before you come to class, see what we just did, get a little refresher on where we were at. If I ever forget to post this stuff on the actual Canvas page, you can just send me out an email that certainly just forgot. It's on my thumb drive, and I can get it posted as fast as possible. So here's where we left off. We pretty much solved this problem 90%, but there's 2 things that we didn't quite get to. Let me just check my color coding. We didn't describe yet the population versus the sample. I'm going to leave off blue because we already highlighted something in blue from up here. So the sample we already gave a hint on as well. When we talk about the 5 W's and how, the who that we identified is the sample. So we can just duplicate our work here. When we said, who is the study about? We said the 32 people tested. So let's just say that again. The sample is the 32 people tested. And just for a quick refresher, these are people that were put on one end of a football field, right in the center. They were blindfolded and told to walk to the other end of the football field. So just ordinary people. And what we want to know is, what is the population? This is something you could potentially, really, really overthink, or it's something you might answer pretty briefly. Any volunteers for what the population seems like it should be in this problem? Sorry, say again?
People who get lost?
Not necessarily people who get lost. We're really wondering about them. That's the why. What happens to when people get lost? Will they walk in circles in the absence of visual cues? But anybody could get lost, right? So our populations are really a bit even bigger than the people who tend to get lost. Would you say all people necessarily? Yeah, go ahead. Pretty much, yeah. And you know what? I would take that as an answer. If you put just all people, I would say that works out great. And this is the point of the course where, again, it's easy to massively overthink this. So if you're going to overthink this and you're going to add more detail, we wouldn't necessarily say all people who get lost because we want to go bigger than that. But we would certainly have to exclude some people, right? We can't have, say, like people who are very young. We can't have people who, maybe a wheelchair would be a good example, but we're thinking about people walking, for example. So we might say all people who are healthy and able bodied. That would be a good clarifying statement because they had to walk from one end of the field to the other. Yet, thinking about it, people in a wheelchair pushing it, maybe something similar happens to them as well. Maybe the dominant arm could get them turning in circles and going out of bounds as well, for an example. But if you thought of the population as just being all people, I think that would definitely qualify on this. You don't have to be hyper specific, in other words, on every single problem that we do. But sometimes the problem might be for a certain class of people. Maybe it's all people who have a certain disease, all people who belong to a certain university. Sometimes it is a good idea to be a little bit more specific. It all just depends on the context of the original problem. This one was pretty broad and wide open. They were just looking for people who could walk normally. That seems to be like the biggest constraint on the population. Well, we did it, folks. Really, part B was just a reminder of the role of sample versus population. When we said the 32 people tested, it was really very brief, but that's okay because the sample comes from the population. And we described the population a little bit more in a little bit more depth. So these were 32 people who were able bodied, could walk normally in this study. Well, again, it's kind of hard to come back to a big, long question like this. Our goal is to try to not break a problem in half, but every now and then some of these problems get a little bit longer, and sometimes we might have to come back to a part B, but we'll try to keep that to a minimum. Any last questions or comments whatsoever on this entire problem? Okay, well, finally, we're getting into some new content. There is a problem in the homework that has to do with the who and the what, but I didn't ask a all 5W and how type of a question. But just keep in mind the who is the sample, the what is the variables, the objects that were, or the things that were going to be recorded on each person in the sample. But to be more specific, we have a whole definition now for variable itself. So this is getting more into the actual nitty gritty, the actual questions you're going to see in the homework. If we were to have posted a quiz on week one, it'd probably be something based off this material here. And once we start getting to exam three, these start to look like typical exam questions at this point. I guess we don't have to really say that. We said examples 1 and 2. Those are more just introducing the course. Those we literally said were not great exam questions, but this one would be. So let's read through the information here. We're told that a variable is going to refer to any characteristic whose values may change from one individual to another. By the individual, we typically mean people in the sample. So we get a population well identified, we gather a sample, and the individuals we make some measurements on, and the variable are the characteristics we actually measure. But the sample doesn't have to be people. It could be a collection of things, objects. It can be pretty abstract. It could be geographical things, like, for example, various lakes in Florida. That's what this problem seems to be all about. It says here in example 3, a really brief example for the wording, mercury is a metal highly toxic to the nervous system. So this is a problem for local flora and fauna and people. They tell us next, below is a small part of a data set from a study that assessed the water quality of 53 representative lakes in Florida. We like that word representative. That means these 53 lakes are about what you could experience in any lake in Florida whatsoever. We're told they're representative. They didn't tell us they were randomly selected, unfortunately, but at least they well represent the state of Florida in terms of their lakes. I like how one lake name is Alligator. That seems so Florida in a certain sense. So looking through this is a lot going on in this kind of data set. The dots that you see down here are just because there's 53 lakes and we didn't show the whole entire data set. It's just a small part. So read those dots as a way of saying, and so on, is all we're saying. So this is just the first 5 rows of the 53 row data set. This number 53 is also pretty important. This 53, we write right in as a number and equals 53 later on down the line. The reason we would do that is n is always going to stand for a sample size. So n is one of those symbols that's really very standardized in statistics. And whenever we read a statistical problem, we're often going to write these down on the margin. The purpose of doing that is it's for the formulas down the line. We're going to have formulas where we have to drop in a value for n, a value for s, a value for y bar, and just learning how to identify them and writing them down ourselves gets us in a great place to really using those formulas once we get to that part of the course. So I think I gave away part of the problem when I said describe the sample. And I said the sample size is n, and n is of size 53, but that's worth doing. So let's describe either the population or the sample. Well, we kind of gave that part away. So let's say right here for the sample, sometimes this is easier to identify based off the information. If they said representative lakes, let's scroll up for just a moment. It might sound like when we said here, the sample is selected at random and it's representative of the population. So sometimes selected at random or being representative is a buzzword that you're talking about the sample itself. So we'll say here, the sample is the 53 lakes selected. Then we use the idea that the population is always going to be the collection of all objects we're interested in. These were 53 lakes that came in Florida. So we would say the population is going to be all lakes in Florida. So this is really a study statewide. They didn't have the manpower or the finances to really do samples on every single Florida lake. I'm not sure how many there are, but it's got to be at least in the thousands, probably in the tens of thousands. You would have to double check me on that fact. I'm not great at geography, but I'm assuming this is a pretty small set of lakes from Florida. That's just what they could afford in the sample. Does that make sense to folks so far on the population versus sample? Awesome. So that's our data set so far. Now, if this was the 32 people that were put in a football field, this wouldn't say lake name. This would just probably say name. And you'd have just ordinary people's names, like maybe Mike Jacobson is in there and so on is what would be listed. Here we have lake name being listed here instead. And that's tricky because you might have assumed everything here is a variable, but that's not actually true. This first column is not a variable whatsoever. This is just the identifier. It's just saying the name of each individual in the sample itself. So let's put out a wording for this already. The lake name is not a variable. The individuals or the sample here is just those individual lakes. And the variable is any characteristic whose value we measure and may change from one of the individuals in the sample to the other. They just happen to be the lakes on this one. Does that make sense to folks so far on this one? Okay, so the variables here are, we went to every single lake. There's 53 of them, just 5 showing. And yeah, 5 showing. They measured the pH, so that's going to be a variable. That goes with, well, no, that this was majorly about mercury, it sounds like. They also looked at how much chlorophyll is in this lake as a ratio of milligrams of chlorophyll per liter of lake water. They measured the average amount of mercury in fish, measured in parts per million. That's interesting because that seems to be what the study is majorly about. Some of these lakes look pretty pristine, like the Popka Lake has 4 parts per million mercury in fish. That's probably close to just the natural baseline in nature. Other ones look sketchy. You probably wouldn't want to fish and eat out of Annie Lake. I don't know how dangerous that is. We'll have to look at the FDA to see if 1.33 is a warning level for us. But that's what they're trying to determine the study, and that's part of the measurements. Notice it said average, though. So this is where the statistics gets a little bit tricky. The population is every single lake, but they can't go and really measure every lake because of limitations. So they went to 53 lakes. They want to know how much mercury is in the fish per every lake, but you can't just go to Alligator Lake and grab one single fish and say, that's the mercury level of every fish in the lake. They had to sample yet again. Here on Alligator Lake, they sampled 5 fish. Not a lot, but apparently there's alligators in that lake, so I understand. Blue Cypress Lake, they sampled 12 fish. They found the mercury levels in those fish, and we hope they grab those fish at random, different spots of the lake, maybe different species of fish, and all sorts of things. Lots goes on into the biology of all of this. And then they found the average at 0.44 mercuries parts per million for that fish. This is also a variable, but it looks like it's just more about how reliable do you think this reading is based off how many fish they got. If we ever saw just one fish, we might not trust the number to the left very much. And a lot of this kind of data has a temporal time component, like we mentioned. Age of data doesn't seem to say a lot, but oh, the data is either a year old. Looks like the study just took a long time to conduct, in fact. Others are recent, whatever that would mean. This is a real study, so if you're curious, I could give you the information on this one. And you can learn what the author said really about these categories in higher detail. So that's a bit concerning because if these lakes are being polluted by maybe some kind of industrial process, year-old data might tell us that the mercury level is inaccurate. Maybe it's gone up, or maybe it's gone down. Maybe something has been curtailed by that industrial process. We just don't know until we look in this a lot further. But those are the variables of the study, and together, all of this makes up the data. The lake name is a sample, it's who was measured. The population is what we want to learn about, all of the lakes in Florida. And what was actually measured are the variables right here. Notice that the variables are kind of different. These ones are all numerical values. We'll call them quantitative down the line. This one's different. It's not numbers. It just seems to be categories. We're saying either the data is recent or it's a year old. Maybe over a year would have been a good category. Who knows? So that's what's going on with our first look at this with variables. The last part of here is, again, a big trick question, really. It's easy to say 6 variables, but you have to know that the lake name right here is not the variable at all. The variable is the measurements you took upon all the individuals, the members of the sample. So this has 1, 2, 3, 4, 5 variables all together. So that's our introduction to what we mean by data, looking at it from another point of view, not doing the 5 W's and how, but mostly focusing on the variable measurements. Any questions at all, folks, at looking at these data here? Okay, next thing we want to do is talk a little bit more about variables. The type of variable you have is going to inform us on how we start to give graphics on this variable, how we represent it visually, what we can do with it. And that's what chapter 2 is all about, displaying and describing different data types, different variables, or different data. So this is the part where chapter 1 is going to segue right into directly section 2.1. We'll visually summarize variables, starting with the weird one right over here. So we need to have a name for this new type of variable, where it wasn't numbers given, just categories. So let's move on to the next part. There's lots of dichotomies in statistics. There's the population versus the sample. That's one dichotomy. There's the parameter versus the statistic is another one. And here's the next dichotomy: categorical data versus quantitative data. Sometimes categorical is called qualitative. So if you like thinking of it that way, there's no harm done. And sometimes instead of saying quantitative data, you might say numeric. That makes sense. They're numbers, so there's no harm done there. So let's work through these definitions, and then we'll take another look at example 4. And by the way, I forgot to mention, I did put a revision on these notes. I changed this part that's right here in red. I had different instructions from a prior textbook that we used to use. This is more in line with what we're actually doing in this textbook. So sorry if you've downloaded these already and printed them out already. This is the big revision on these notes right here. So first, let's talk about categorical variables. The punchline on this is that one is the categorical variable right up here. What a categorical variable does is it takes the people in your sample or the lakes in your sample, whatever your sample might be, and it categorizes them in the most logical way possible. So that could be stuff like zip codes. So if our population is, say, all Idahoans, we might categorize them according to where they are geographically. Zip codes might be a good way to do that. And that's dangerous because, zip codes, they look like numbers, but they're not quantitative whatsoever. So that's one thing that's a big thing to worry about already. The zip code is not quantitative. And one way you can kind of reason through that is one reason a zip code is not quantitative is if you had to say a set of 30 zip codes, it's just a big set of numbers, taking the average of those zip codes wouldn't really inform you anything. It's not going to be a new zip code. It's not going to tell you a region in the United States whatsoever. So if taking the average of something doesn't make sense, it's categorical, even if it comes in as a number. So let's say zip code is not quantitative because taking the average has no meaning. No one can stop you from doing it. It's just that the number you get is of no value any longer. So another example might mean, let's say, oh, I guess I actually said that right here. Sorry, I don't know why I felt like I had to rewrite that comment. I guess I should read the whole line. Another examples of, say, something that's categorical could be maybe blood types. Say A positive, A negative, B positive, B negative, universal donor. I think that's O negative. Correct me if I'm wrong, a little rusty on biology. So blood types would be categorical. You'd be taking, say, if your population is all Idaho, just categorizing due to blood type. And many, many other examples. Anyone have an example that you'd like to share? Kind of hard to think of something right out of scratch, right? You know what makes it hard is I never gave a population. So we'll give a population on this one so we can come up with some interesting variables. So I have a categorical variable of zip code, another categorical variable of blood type. It seems like we're talking about people. Let's say the population is all Idahoans, and we might as well write that in. Population, all Idahoans. It's always a weird word when you actually spell it out, but there it is. And we can categorize all Idahoans by their zip code, their blood type, and who knows what else we might do. Maybe, what is another good categorical variable? I was going to say eye color, but not sure how useful that would be. But that would work. That'd be putting people into categories. So you could do all sorts of things like that. I'm not sure what this study would be all about. So this is really more about just emphasizing what the variable would look like than anything else. Any questions at all, folks, about categorical variables? Okay, very often they look like this: blood type, eye color, but they could also look like, say, your student ID number or zip codes. So watch out for things that do come in as numbers. That doesn't guarantee it's a quantitative variable. It could still be categorical. So let's now take a look into the quantitative variables. Quantitative variables are sometimes a little bit easier to spot. It's where averages does make sense. So for example, if a quantitative variable is height, it makes sense to ask about the average height. We could record everyone's height, take the average, and that is another height yet again. So it says variables such as ages of individuals in a sample are numerical, since it does make sense to find the average age. Another thing you could put on here that's kind of helpful is quantitative variables often, I don't want to say this is a 100% rule, but it might as well be very close to it in practice. They often have units. So if there's a unit associated to that number, it's almost guaranteed that that number is quantitative. Zip code doesn't have a unit whatsoever. It's just a stretch of digits. So let's do an interesting example on this one. Let's say for our population, it's going to be all ISU students. Now that's a huge population. ISU's been around since I should know this number, like 1950, I'm just going to say. Let's just throw that out there. You could research that and get a better number. So if you're talking about all ISU students, again, to say what you really mean about a population, you have to be specific. What I mean is probably all ISU students registered for fall 2025. And again, that's a pretty big population too. Some of these students are not even in Idaho. We have students that are all over the nation. Some of these students might not even be in the United States of America. We have international students that participate through purely online classes, for example. But let's just stick with this. All ISU students registered for fall 2025. Still a big unwieldy population, but a little bit more narrowed down now. We might say a quantitative, for examples of quantitative variables, let's list these out.
What we're gonna say, we're gonna do shoe size, what would that be?
Well, that would be a great one. Let's go to quantitative. Now that you say it, I was about to put it down. That would be a quantitative variable, but now we have to decide on a measurement, which is suddenly really, really tricky because sizing gets complicated, right? You have sizing for males, you have sizing for females, and those don't always correspond to the same unit, but we could still try. We're just going to have to invent our own thing. We might say for a quantitative variable, shoe size let's say we just decide to measure them in inches. We're going to take an actual tape measure. We're not going to worry about anybody's own proprietary sizing chart. We're just going to measure them ourselves. So that would be a bona fide quantitative variable as well. Let me not abbreviate that because that looks kind of weird if you read it. Shoe size in inches. What would you say is another interesting quantitative variable? You know what else might make this hard? We know what the population is, but we don't know why we're doing a study that's going to take a random sample of these ISU students. Sometimes what makes this a little bit easier if you give this a purpose. Imagine you are a high-ranking individual in the administration of ISU. Maybe you're President Wagner, or maybe you're one of his crack team that does a whole bunch of things for ISU. Maybe you're affiliated with their marketing, and your whole goal is learn about the population of ISU student body for the purpose of making better marketing materials, increasing enrollments. That's what the State Board of Education in Boise would want you to do. That's your job, literally, as a state college. So if your job is to increase enrollments, what information do you want to know about all ISU students as they are right now? Yeah, go ahead. Absolutely. If we know their most popular major, I think we're pretty big on things like nursing, dental sciences, and so on. Their marketing could be attuned to that, and that could drive in a lot of extra students just by focusing on that kind of marketing. So we might say, oh, but the one trouble is the major would be categorical, right? Because we would say nursing versus business versus those other things, but you're absolutely thinking around the or along the right kind of lines. So we would put that up here with categorical. I like the way you think though. Maybe another one just to throw an idea out is maybe number of credits completed. That would be interesting because now you'd have an idea of how many students are about to finish their program. How many students are graduate students, for example, would be interesting. And all sorts of other things could be determined from that. That could drive the marketing. For example, if they know that maybe these are fake numbers, but they knew that 40% of ISU student body has completed less than 40 credits, maybe that would tell them that they should focus on some interesting services for more tutoring, more services for students that are at the freshman, sophomore level, and they could use those in marketing materials to drive more students as well. We have a huge student body of newer students, and we're going to really focus on supporting them. Could be the message, for example. Anyone think of another interesting piece of data that an administrator would want to record?
Student playing sports.
Yeah, absolutely. Let's see, how could we phrase that though? So we'd have to be for the individual student, and we could say maybe number of sports and struggling on the wording, but I like this example. Number of sports the student is affiliated with. Maybe you'll play for ISU football. Maybe you're on the football club. Maybe you're on the fencing club, anything along those lines. Maybe you're in the wrestling club, or maybe you wrestle for ISU. Let's say that's all affiliated with. So this is a pretty big category. But for every single student, you can put down a number. Yeah, absolutely. So number of sports the students affiliated, or we could just say, yeah, let's replace sports with activities. That's a little bit of a broader category, but it might be more descriptive and more informative to the administration. Number of activities the student is affiliated, I feel like I'm missing a word here, with, and we can keep on going on and so on. One that's I think would be pretty interesting is number of miles the student commutes to their main campus. From so a lot of students, it's going to be 0 miles if they reside on the main campus. Or maybe for the fully online students, we'll have to put in a de facto 0 or just not applicable for them. But for people like us on the satellite campus, you might have a pretty decent commute. Not everyone lives in Idaho Falls. Some people can be a pretty good amount of miles out. So Loads of examples you can come up with. Anyone have any burning one you'd like to share before we move on? Yeah, 49 miles for you. Yeah, that is a good way to go. Sorry about that. I know the experience. I had to commute from Idaho Falls to Pocatello for a couple years myself, 5 days a week, and that was really rough on the gas. So yeah, it gets a little bit rough, but it's only 16 weeks. We'll get through it. But other questions or comments at the moment? Okay, so this is the idea between having a categorical versus a quantitative variable. And let's take another look at this example now that we've thought about those definitions. All we want to do here is determine which variables are categorical and which variables are quantitative. And I believe we color coded this way. This one's kind of a fast example because we looked at the data set before. Let's think about our hack though. We know for sure that we have a quantitative variable if there is a unit. Now, pH has a unit. Turns out to be a complicated unit, but it belongs one. It's like something about the number of hydrogen atom activities and ions. I'm rusty with chemistry, so I can't tell you exactly, but it has a bona fide unit. So we can say for quantitative, pH absolutely would qualify. Chlorophyll, they just said the unit. Number of milligrams of chlorophyll per liters of the lake, abbreviated as milligrams per liter. So that would be our next quantitative variable. I would probably abbreviate this one as chloro, or why not? We can take the time to just put that all in. Chlorophyll. You don't necessarily have to bring in the unit when you state the variable. This one is an interesting measurement, but it also has a unit, parts per million. So this is the average mercury in fish. Let's abbreviate this one, average mercury. This one's turning out to be not super exciting in the sense that it's all quantitative until we get to the last column. But number of fish sampled, yeah, this has a unit. It's 5 fish, fish being the unit, 7 fish, and so on. It's all right. Number of fish sampled. So this data set came with 4 quantitative variables out altogether. And the last one, this was one where they're categorizing every single lake. Annie was done recently. Alligator Lake was year old. No one wanted to go back, I suppose. So this is the categorical data of the data set. Wrong color coding on that. Our whole goal on this was just to place this in a new category all to its own. So let's say here, categorical, age of data. Turns out section 2.1, we'll get into next after these notes, is going to be more about the categorical. Yeah, go ahead. Yeah, that's a terrific rule of thumb. The only way it could be slightly dangerous is if we had a new category that looked like this. Let me try to get back in there. Hang on, let me fix this table. We had a new category. Let me go. Let's just hack our way through this. If we had a new category that looked like this, here's our table extended. And a new interesting category could have been zip code. You know what, let's leave this in. Let's pretend this was our original data table just as another example. I don't know great Florida zip codes, but let's just make up some numbers. No, let's actually see if we can find one. Florida zip codes typically begin with the digit 3. So 5 digits begins with the digit 3. That's kind of a cool little hack. So 3, 4, 2, 1, 0, 3, 5, 6, 7, 4. Though the only problem here is these could be fake zip codes. Not every set of 5 digits is a real zip code. But if our data looks like this, 37888, 33000, 34025, and then finally dot, 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 then this is the only exception to the rule that you stated. Almost always, if you see the numbers, it's going to be quantitative, but think in terms of, is there a unit? Can you talk about the average of pH? You could do that for these, but the average of zip codes wouldn't be very sensical, wouldn't have any meaning. And also there's no unit to a zip code. It's not time, it's not distance, none of the above. So this is the only thing to watch out for. Categorical would be also zip code for this problem as well. Well, any questions about that so far? Thanks for asking about that. That is a fantastic rule of thumb. I would have to work hard, honestly, to come up with an exam question where that would be the big curveball. So it's a good thing to look at first. Which ones are numeric, or which ones come as numbers so that they're quantitative. Then just give it a second look. Does it look like it have a unit? Does it have a unit? Would the average value make sense with it? And then you can be in great shape. Well, we have just one more exercise in this set of notes. A lot of the data that we looked at has been in tabular form like this, but sometimes the problems can come in this kind of category. So it says, kind of like a flash just review of all these concepts, classify each of the following variables as either being, once again, categorical or quantitative. This problem doesn't ask you to give an explanation, so we just need to give that as a response. So, any volunteers for what part A would be? Absolutely. Weight feels like a quantitative. It's going to be a number, right? They also gave us the unit in ounces, so that's the second red flag. It's just got to be a quantitative variable. This one feels like a different thing, but it's a number, so that helps us. Items is literally a unit. It's not the most complicated unit. It's the number of items purchased by a grocery store customer. And a grocery store would want to know the average number of things purchased. That's really important information for that store. So would you all agree that this one must be quantitative as well? Awesome. Let's put down quantitative. I totally agree. How about for part C? Brand of a cola purchased by a convenience store customer. What does this one feel like? Yeah, absolutely. You can imagine, what does this data look like? Imagine a table like this. You're saying brand one, maybe it's Coca-Cola, brand two, maybe it's PAB or TAB, I forget what all these brands are, and so on. These are just going to be just ordinary words describing these things. So that tells us there's no numbers here. This is definitely categorical. So this is pretty much the name of the game on this kind of question. This could be one of those questions on exam that are really fast, for example. This could have been our quiz for the week if we threw a quiz at ourselves on this week. Going along the same kind of guidance, it says amount of gas in gallons purchased by a gas station customer. That's something, say, the local gas station would want to know about. There's a unit in gallons, and you pump out a digital number on the gas station, so quantitative as well. When it comes to the type of gas, regular, premium, diesel, and so on, would you all agree that that's got to be categorical at this point? Yeah, absolutely. So this doesn't have any numerical value. We're just taking every transaction and literally placing them in a category. Was this a diesel transaction? Was it premium, regular? That's all the categories. So that makes it categorical. And we did it, folks. We finally got to the end of the notes. We took a lot of time with this section, but I think it's time well spent. It was mostly introducing the course. And the last few examples are a lot more closer to what you're going to see in the homework, as well as quizzes and potential exam questions. Well, any last questions or comments at all getting through these notes? Okay, big things to recall from these notes are the differences between the population and the sample, as well as categorical versus quantitative variables. That's what we're going to focus on when we carry forward into the next set of notes. So let's go over to next, section 2.1. Okay, well, example one, this one's not fair as a question right at the moment because we haven't quite done a problem like this before. But it would be a pretty fair question after we've gone through the experience of these notes and done the homework questions and so on. Here comes the categories again, same color coding. We have two major data types that we're concerned with in statistics, the categorical data versus the quantitative data. Chapter 2 is all about displaying this data and describing it well. And I mean, that makes sense. Sometimes the best way to understand information is just to see a picture. A picture is extremely valuable. A lot of people can glance at an image and learn more about what's going on in the data than any amount of text you might write up. There's a lot of ways to describe categorical data. There are things like pie charts, for example, which are sometimes very interesting. But the major things that we're going to look at is a bar chart. Or you could say bar plot. Those would be considered completely synonymous. And we've seen bar charts, bar plots pretty much all our lives going through the education system. Advertisement and media just throws them at us. But let's load one up just for the sake of telling the difference from it and a histogram. Let's just look into a bar chart. We're probably going to get lots of them here. These are the typical bar charts. So here we have categories A, B, C, and D, nothing too specific about it. And the bar chart is just saying how many people the sample belongs to those categories. It gets a little bit more confusing when we go to quantitative data. And still, there's lots of ways to display a quantitative data. You might do a dot plot. We'll look into those. Another one's going to be a box plot a little bit down the line. But the major one we'll focus a lot of attention on is going to be the histogram. So this gets a little bit confusing now when you put down histogram on this. Have people heard of a histogram before? Sometimes it's often a new word. That's awesome that you've heard of that before. That gives us a big upper hand. Let's just look at a random histogram off the internet. So it's spelled hist, then o-gram, basically. So for a random histogram, let's open a new tab so we can compare these against each other. Here's what they look like. Notice the familiarity. That's the danger. They look really, really similar to the bar charts, right? So if we can tell the difference between the two, that's already a big upper hand. Notice in the bar chart, categories are on the horizontal axis. On this one, categories are months. This one's a little bit more involved. There's multiple categories going on at once. We're mostly concerned about these kinds of categories at the moment, just one variable at a time. The histogram is different. This is not a very good histogram. Traditionally, a histogram looks like this, where a gap only means no one belongs in this range. Notice this time the horizontal axis is the quantitative variable, ranging from age 20 to 100. Let's look at this one, height in feet. The interesting thing about this is, if you're talking about height in feet, there's a definite ordering to this, right? Whereas if you went to other kind of categorical data, well, there's a definite ordering to A, B, C, and D. The alphabet gives the order. But there's no order to red, blue, green, yellow, and pink, right? You could sort these however you like. And when you resort these, a different shape emerges. Never with the histogram. we inherit the natural ordering of numbers. So a histogram always has a certain shape that we can talk about. So a histogram puts the rectangles together. The shape never changes. We would never take 80 to 85 and put it way out here. We're just trying to deceive people if we ever do that. Whereas in a bar chart, sometimes it's just however you decide to order things. Other times there might be a natural ordering, period 1 through 5, or maybe the natural ordering is months of the year, but that's not always set in stone. In either case, bar charts always have gaps. So that's the difference between the two. We're going to study them one at a time, but I felt like we should know what we're looking at if we say quantitative is associated with the histogram and categorical is associated with the bar chart. Deceptively similar looking, but very different in the actual use and function. Well, any questions, folks, about those two graphic types? Okay, well, example 2 is meant to be just a really fast kind of problem. It says, of the following data sets, they didn't give us a data set, it's really just a description of the data set. Which would you display with the bar chart, and which would you display with the histogram? And before, when we were saying data is quantitative categorical, it didn't ask for an explanation. You give me an answer, I'm totally happy with that. But occasionally, sometimes these problems, they do want an explanation. If I ever say briefly, it means doesn't even have to be a complete sentence. It could be a one-word justification, and then you're done. So the first one says, a record of the gender of selected individuals labeled male 0, female 1. Sometimes statistics is recorded this way just to make work with computer software a little bit easier. It's kind of weird to make that kind of assignment, but it's done quite often in practice. What kind of data would this feel like? I heard some say categorical. Yeah, absolutely. Even though there's numbers, taking the average of these numbers might not be informative in the way we might think. So it's really all about the fact that it's a category. 0 just happens to correspond to male, 1 happens to correspond to female. And so we'll say, well, if the data is categorical, we would use the bar chart. Recall, I was asking which would you display with the bar chart and which with the histogram. So here we would just say bar chart, since data is categorical. And that solves it for that problem. So really, it's just really a concept question more than anything that we're going through on this one. Any volunteers for what display we would use on this one? Is this the bar chart or is this one the histogram? Yeah, good call. When it says a record of age, it's numeric. They gave us a unit as well. It's going to be measured in years. So that means it's going to be numeric, or quantitative data is the word I would usually use, but numeric is completely synonymous. So the answer to this one is histogram. Histogram, since data is quantitative. And that's how this problem kind of proceeds. Yeah, go ahead. Yes, absolutely. Yeah, so it could be just a one-word answer. In fact, let's do this on these first two just to emphasize. If you said, well, maybe on the next two, because I put in a big gap on those. But if you just said histogram, comma, quantitative, that'd be a perfect way to respond on that as well. So that's what I mean by briefly. Sometimes I throw this in as an exam question extra hint, just to let you know you don't have to overthink this one. You don't have to say a whole lot, because it really is easy on a real exam to not know what's really expected about the level of answer. So that's a dead giveaway. Even a one-word statement can be your explanation, and it's totally fine. In fact, that was our explanation here, right? We just said categorical bar chart. That's how we explained it as well. Well, the next one is a record of heights in inches. So again, that's our dead giveaway. It's going to be a histogram. And I'm going to say, write this response as you were indicating. All you have to say is quantitative. You don't have to write out a complete sentence. I mean, this is not even grammatical. I don't have periods or commas or anything. That would be enough to qualify. How about for part D? What would you all use for this one?
You said it earlier.
I did, didn't I? I forgot all about that. So whenever it comes to blood types, these ones are always categorical. And this one doesn't have the RH factor, but that just means it's different categories this time, just the four. So here, this one is going to be a bar chart. And I'll just give the very brief description, categorical. So those are how we're going to start plotting our data according to just what data type it is in the very first place. One word of warning is histograms are actually not easy to plot. There's a lot of stuff that happens when you construct one of these. Typically in statistics, we let computer software do the heavy lifting for us. So I'm never going to ask you to plot by hand a histogram. I've done that in the past, but I felt like we were spending more time just doing unnecessary math, and we learn less statistics whenever we do that. But you might plot a bar chart. It could be a quiz problem, potential exam problem. Won't be anything too major. So we'll do one of the notes as well, just in case that ever comes up. So now that we've looked at all that, let's take a look at, let's see, we have about 13 minutes of time. I was thinking about going through this problem right here about frequency distributions for categorical data, but this looks like it's going to be a problem that might take a little bit long to get through. So let's take this rare opportunity here to skip down a little bit further in the notes. Example 4 is one we can fit in with the amount of class time we have, and we won't have to split it in half. So this is a really interesting problem in its own right. Example 4 says, here's the number of babies born on each day of the week in year 2006 for a particular city in USA. To be completely upfront with you, if I have a description like that, it sometimes means this is fictitious data. It's mostly here for a good example. If I had a little more context, then more often than not, that's real data. Like even the lakes in Florida was real data as well. But here's the data. We want to describe the variable in the study, and this is already kind of challenging in a certain sense. I knew I had Excel up for a reason. Let me pull that up again. Even though there are two columns on this data set, there is in fact one variable, and this is really challenging to see why. Here are all the births that occurred, and there's loads of them. But if you were going to compile this data set, imagine what it would really look like. It might look like this. Birth, number. We're going to go from 1 until we get to the total number of all of these different births for that city in 2006. So 1 is going to be the first birth, and there's going to be a lot of them, right? 2 and so on. So here's birth number, and it doesn't have to be birth number. This could be the name of the baby, or maybe a social security number. The social security department might take a little time on that. So maybe social security number is not a good one, but it could be the parent's name, something like that. I'll just go with a birth number as opposed to baby names or something along those lines. Then it's going to be day of the week. So when this data set's actually being built, here this is going to be where the dots are, the and so on. There's lots of births in here. But this is how the data set is going to start to get propagated. Maybe the first birth was on Monday. The next one was on Friday. Maybe a duplicate for the third one, Monday. Saturday, I'm just making up fictitious data, so this is just a visual of what it would look like. Maybe Tuesday, Tuesday again, and Friday again. Then for everyone down the line, just more and more. So this gets a little bit tricky in a certain sense. They took all those births and they put it in this table right here, but it really hid something from us. What it hid was what the data really actually looks like. Let's put in an extra display that we came up with. So now this is the original data being built up as a data set, and it might remind you of, shouldn't have closed the chapter 1 notes, but it might remind you of those lakes in Florida. And one thing that was critical about those lakes in Florida is the first column, that was just us telling the individuals, the members of the sample, apart. It wasn't a variable at all, was it? It was just the names of the lakes. Same problem over here. The birth number is not a variable whatsoever. The variable is the day of the week. We're taking every single birth in 2006 in the city and categorizing it for what day of the week, what did the birth occur on. So this one is not a variable. This right here is the variable. And if this is all you saw, the data table, that's pretty dangerous, right? Because same kind of issue here. Let me just remove this extraneous stuff. Day, that's the variable. And births, oh, let me get off of that. There we go. Births right here is not a variable whatsoever. It's just a way that we summarize, that we tallied how many births occurred on Sunday, 7,587, Monday, and so on. This is really very tricky in a way, right? I like problems that go like this because it kind of makes it a little bit more clear. What is the thing we're just trying to identify as a member of the sample? What are the actual variables? But when our categorical variable is summarized in this kind of way, it hid something from us. It hid the fact that there is just one variable right here, and it might lead us to say that this is another variable. We might call it quantitative, but that's not the case for this. This is just an extra summary about the actual categorical variable. So this is a kind of question that is really, really tricky. It's unfair unless we think about this at least once. The variable to study is day of, let's just say day briefly, because that's how it came in on the original right here. Day, and it is categorical. Well, I feel like I could have written these instructions a little bit better now that I'm thinking about it. When I say describe the variable, I think a better exam question would have been describe the variable of the study by determining what it is and if it is categorical or quantitative. Let's put that in as an official edit on this one because I think it's kind of vague what I mean by describe unless I said that very, very explicitly on this problem itself. I want to know what is the variable and if it was categorical or quantitative. Sorry for those after the fact edits. I try to minimize that as much as possible. Does that make sense to folks on what the variable happens to be on this one? Okay. Again, it's better when you see this kind of data. Imagine you're the researcher. You're filling out the data set line by line by line. It's going to take a while for this city. What would your data set actually look like? And that's what this is right here when we start filling in the notes. Imagining what the original data looks like. Now, you might have noticed something is off about this data, but let me just run it by you. We put it in a bar chart. This data is hard to understand just looking at it numerically, although you might have noticed Tuesday's weird, right? It has an extra figure. This is a 6-figure number, whereas above and below are 5-figure numbers. But when you put it in a bar chart, It looks even weirder. Would you say that there's an explanation for this? Or would you say there's something off about the data? A lot of people have different opinions and views on this.
I think there's an error.
Yeah, it looks like something is a little bit off about this. It says, what can you say about these data by this considering this display? And well, right off the bat, you might say Tuesday has nearly all the births. That seems weird. I mean, maybe Tuesday does have more births. You might justify it as maybe if people are going into labor over the weekend, they might have birth induced maybe on Friday or more likely on a Monday. Less births on the weekend might make sense. And if you're in labor over the weekend, the doctor might be more available on Monday or Tuesday. Maybe these should be higher. But it's hard to imagine a hospital that does something like 80% maybe of all of its births on one day. That would be the craziest day in that hospital ever, right? It'd be just a complete madhouse. Something is wrong about this data. There appears to be, we could call this an error, a mistake in the problem. Sometimes a way to describe this is there appears to be an outlier. An outlier is something that doesn't fit the pattern, and we've got no explanation for it. Maybe an explanation is coming. Maybe if we think about this hard enough, we can justify why so many births are happening on Tuesday. Or maybe someone made a mistake. I bet you when this data was typed in, someone hit the 3 one too many times, and that real data should look like that. Slightly more on the last 4 days of the week, not so many on Saturday or Sunday, and it gets going on Monday, a little bit lower. But this is the original data we were looking at. Sometimes when you see data, the graphic is going to really tell you, does this pass a sanity check? Or sometimes this is called a smell test. This looks really, really weird. And sometimes I've looked at it and thought it seemed normal. But the more you look at it, you would have to have so much manpower on Tuesday that the hospital is just not even running efficiently anymore. And there's got to be a really good explanation for that. This appears that there's no further really good explanation for this outlier. So it's probably an error, like was mentioned. This appears to be an error in the data. So you might be asked to say something about a display of data like this one that's categorical. We'll do it again on a different example. But sometimes if you're told to say something about data, look for the most weirdest looking feature possible. That's definitely something to always talk about. And outliers are things that don't fit a pattern. We'll say a lot about outliers throughout the class. This is the outlier in this data set. Any questions about this so far? Yeah.
Make an outlier so we can notice it or talk about it in general?
It's possible, absolutely. But I think I probably wouldn't do it by, like I did on this one, forcibly making an error on my own. It'd be something that happened more naturally as a real problem. So something that wasn't a mistake, something that's really going on in the data. So outliers can come up in that way. But this one is a pretty extreme example. I don't think I would do this as often on a real exam. Other questions so far? Okay, well, have a great weekend, folks. We'll come and finish out the middle problem in these notes, example 3, after we come back on Tuesday. So have a great Labor Day weekend. If you have questions and you're working on Friday, I'm pretty available on Friday as well. That's usually kind of like a grading day for me as well. So don't hesitate to reach out. Otherwise, I'll see you all next Tuesday. Yep, have a great one.